I'm Eric Linask. I'm here at Cloud Expo in New York. I'm talking with Nimble Storage's Gavin Cohen. Gavin, good morning.
Good morning. Thanks for joining us here.
Maybe get us started. Just a quick overview of who is Nimble Storage. What do you do?
That's a great question. So Nimble Storage company started in 2008, and at the time, our founders sort of had this really strong belief that the whole storage industry was very much ripe for disruption, and for two reasons. One, that flash technology was just starting to become a mainstream technology to be considered in storage, which completely changes the way you think about designing and building a storage system. And the second reason, which is sort of quite interesting, is there was this belief that we're in a world where everything's connected, and this show's certainly been talking a lot about Internet of Things. But by connecting our devices and allowing us to remotely monitor and manage the systems, we're able to do some really interesting things that had never been done before in storage devices. So that's what led up to the foundation. So we released our first product in 2010. Since then, we've been growing at what we believe to be about as faster than any other storage company's ever grown, to the point where today we have more than 5,500 customers worldwide using our systems across about 10,000 systems. So it's been a very successful company. We IPO'd in end of December 2013, and we're now listed on the New York Stock Exchange.
So you talked about some of the way the industry is changing and evolving and maturing. How have some of those, the Internet of Things and other things that we're seeing going on now, how have they changed storage requirements and what you need to do in order to address some of those new opportunities?
Yeah, no, that's, again, great question. So the first thing is, there's two things that always happen in storage. You need more performance and you need more capacity, right? And that's just happening everywhere, from your phones all the way up to the biggest enterprise environments. And what's sort of the fault in storage is that traditionally it's been designed around disk and disk spindles. And it gets really, really hard with disk to build systems that just keep performing, because ultimately disks are mechanical devices and they're constrained by how fast you can move the head across the disk. So what we've done is we've combined flash and disk, and by doing that, we're able to use flash to completely flip around the dynamics of performance, where there's a kind of a picture up on the wall, but where in a little 3U appliance, we can deliver the same kind of performance and capacity than the best of our best competitors can deliver in a stack this high of their highest end systems. And because it's a modern device, it's far, far easier to manage and deploy and monitor and just use in general environments. And so the world's very much changing. We've seen in the whole market, the big vendors, the EMCs and the NetApps, have both had very flat to declining storage businesses, which has been really interesting because traditionally they were all growing at a very rapid pace. And what's happening at the background is vendors like Nimble are just growing at an almost exponential pace to sort of become that next generation storage vendor.
So when you talk about combining a disk and flash storage, how are each of those different types of storage used in the appliance?
Right, no, that's a great question. So I won't go too deep technically, but we're doing something interesting here. The traditional way people think of disk and flash together is you think about tiering them, where you say, I'm going to write to the faster one, and then at some time I'm going to move it down to the slower one in place and move something slower to faster. That's a great idea, but it's not completely non-dynamic because it doesn't adapt to what's actually taking place today, right? So what we do is something different. We have disk and flash doing two different roles. The first thing is when you write to our systems, we, believe it or not, we actually write directly down to disk. But traditionally, you wrote to disk where you wrote one transaction at a time, and that's what causes the mechanical movement on the disk. The head has to seek to write that block to disk. Instead, we're using our CPU power and non-volatile memory so that when the hosts write to us, we take thousands or tens of thousands of these small transactions, We then compress them and we aggregate them together so that we have a very large amount of compressed aggregated blocks of storage, and then we write them sequentially to disk. And by doing that, we can take essentially slow disks and turn them into something that's fast or faster than flash drives. And we can do this day in, day out. So we can really, write at an order of magnitude faster than anyone else can to disk, even though what's being written to us are these small random transactions. And then on the read side, this is where flash comes in. We use flash as a very large cache. So dynamically, we actually cache all those the hot blocks, the ones that are actually in use at the time, through the flash, so that you get this read performance out of the flash instead of off disk. And combining that sequential writing of random data with caching all the reads, we end up with what looks like pure flash-like performance, only we're actually leveraging the cost benefits of having quite a lot of disk and capacity behind us, and that works really well.
Are you able to scale your storage system, to meet the growing needs of really what's become a data economy?
Sure. So we actually scale in 3 dimensions. So our starting point is this sort of 3 rack unit brick, and that has some amount of capacity, some amount of performance. And then the way that we scale is that same head, or that same controller shelf, we can grow it by adding more capacity shelves, and we can keep going from about 8 usable terabytes to somewhere around the 500 plus terabytes behind one controller. And then we can take that same controller and we can scale it out by adding additional nodes, so that in a single system, non-disruptively, we can go from that 8 terabytes in one controller all the way to about 2 petabytes of usable capacity across a number of nodes in a scale-out configuration. And it's all done in real time. From a host point of view, nothing changes. You just keep reading and writing to our device. You just keep growing it by adding more of these 3U components. So yeah, very highly scalable.
And in that scenario, there's really no performance degradation?
No, I mean, you'll actually, when you scale out, you actually linearly grow the performance. So if one node can deliver 150,000 IOPS, when you add your second node, you get 300,000 IOPS that gets delivered across the storage pool. So.
Fantastic. Gavin, it's been great chatting. Thanks for joining with me. Good luck the rest of the show.
No, likewise. Thank you very much for dropping by, and really appreciate it. Thank you.